Hello, good morning, students. In the last lecture, we had studied about isomerism in alkane. In this lecture, we will study about the conformations in alkane. So what is this conformation? We know alkane contain carbon-carbon single bond, and this carbon-carbon single bond is formed by overlapping of atomic orbitals, and this single bond is a sigma bond. So this single bond, it is sigma bond, is a cylindrically symmetrical, and the single bond can be rotated. It undergoes rotation, and by rotating this single bond, the bond angle between the hydrogen atoms, carbon and hydrogen, that changes. And by rotating this bond angle of carbon and hydrogen through 360-degree, we get different arrangement of carbon and hydrogen in the same alkane, and that gives the different arrangement that is called as a conformations. So the resulting arrangement of atoms in a space about the carbon-carbon single bond are called conformations. So this rotation of carbon-carbon single bond that take place through 360-degree, and the phenomenon of existence of conformation is a type of stereoisomerism. In chapter number 14, we had studied different types of isomerism. So stereoisomerism is one type of isomerism in which this carbon-carbon single bond rotation take place, and which gives the different arrangements, and that is called as a conformations, or also called as a conformational isomers. So out of the infinite conformations of ethane molecule, the two extreme are called staggered conformation and eclipsed conformation. Staggered and eclipsed conformation, and that is represented by Sawhorse formula and Newman's projection formula. Again, remember this, that for ethane, a very simple example of alkane, there are infinite number of conformations are possible, and two extreme conformations are staggered and eclipsed conformation. They are represented with Sawhorse formula and Newman projection formula. This we will study in detail now. Consider this carbon-carbon single bond represented with a single line as a bond line formula. As we had already studied in chapter number 14, that a bond line formula, this carbon atoms are not shown. So here around this carbon, first carbon, there are 3 hydrogen, and the second carbon bonded with a single line. So this is a second carbon, again contains the 3 hydrogen. See that this carbon at the top and carbon it is below, they are maximum away from each other. In this way, in the staggered formula, this carbon 1 and carbon 2 containing hydrogen, they are maximum away from each other, and this type of conformation is called as a staggered conformation, that is represented with Sawhorse formula. In the same formula, if we keep this position of hydrogen on carbon number 1 is the same as in the staggered formula, And if we rotate this positions of hydrogen, that is, here it is wrongly shown. Actually, this hydrogen must be above, that is, it is rotated through 180 degree and it must be above at this position. So it is a wrong conformation given in the textbook. This hydrogen at the second carbon, which is highlighted, it must be at the top position here. It is exactly opposite side. So all hydrogen on the second carbon, they are must be at the opposite side, and that conformation is called as a eclipsed conformation. In the eclipsed conformation, these hydrogen atoms at the top from carbon 1 and carbon 2, they are very close to each other. Similarly, second hydrogen, similarly third hydrogen, they are very close to each other. That is called as a eclipsed conformation. These are Sawhorse projection formula for representation of staggered and eclipsed conformation. The second type of conformation is a staggered, that is, staggered and eclipsed conformation can be represented with Newman projection formula. In the Newman projection formula, in the circle at the center, there is a one carbon shown with a bond line formula. This front carbon, that is the first carbon, have 3 hydrogen. They are equally apart from each other, and there is a carbon-carbon single bond. Now, in this molecule, we are looking through carbon-carbon single bond, and therefore, this carbon-carbon single bond is not visible in this projection formula. But the back carbon or the second carbon, that we cannot observe because it is exactly behind this carbon number 1, but we can see these hydrogen atoms present at the circumference of the circle, and these hydrogen atoms are the hydrogen present on second carbon or the backside carbon, and this in this conformation these hydrogen atoms are again maximum away from each other, called as a staggered conformation. And in the eclipsed conformation, again these positions of this hydrogen on the second carbon and the first carbon, if you observe, they are exactly one behind other. Similar to carbon, these hydrogen atoms are also, they are exactly one behind other. So we cannot see, actually it is in the two-dimensional diagram, it is shown one behind other. That is first carbon, it is in front of second carbon, then hydrogen to the left side on first and second carbon, they are one behind other. Similarly second, similarly third, and this is eclipsed conformation. So in this way, this ethane molecule can be shown with Sawhorse projection formula and Newman's projection formula for ethane molecule in the staggered and eclipsed conformation. So the most stable conformation out of staggered and eclipsed is the staggered conformation is most stable, and the eclipsed conformation is the least stable conformation. And that is about the conformations in alkane. Thank you.